In this triad exercise, we are asked to determine whether the points 3, -2, 5, -3, and 1, -1 are collinear. So let's see. I went ahead and wrote out, we use determinants to determine if these points are collinear in this problem. And in order to expand according to any specific values, we have to remember this plus minus configuration. Plus minus plus, minus plus minus, and plus minus plus for the last row as well. So what it means if these points are collinear is that x1, y1, 1, x2, y2, 1, and x3, y3, 1 is going to equal 0. So x1, y1 is the point 3, -2, so x1, y1, and we could use any of these, they could be in any order, but for now we're going to use them in the order that they're given. So this is x2, y2, and 1, -1 is going to be x3, y3. So if we just substitute those points in, what we get is 3, -2, 1, 5, -3, 1, and 1, -1, 1. And we're going to determine what does this equal. If it equals 0, then we can say that the points are collinear. So we're going to expand according to this last column here. And the reason being is because they're all 1s. So when we evaluate the determinant by expanding by the minors of this third column, we just end up with the minors themselves. And we have to remember that since we're using this third column, it's going to be plus, minus, plus. That's going to be the signs of the minors that we expand using column 3. So I'll go ahead and write out there's an invisible, but I'm going to go ahead and write it out 1 in front of all these. So let's expand according to that third column of 1s. So what is that going to give us? That's going to give us, let me go ahead and draw in brackets instead of just the lines to match what the course is doing. So we have this invisible 1, but I'm putting it there. You don't need the 1 because we're just multiplying everything by 1 in each instance. So 5, -3, 1, -1. So we're taking this first 1 right here, and then it's the bottom left. It's everything that's not in the same row or in the same column. So 5, -3, 1, -1. 5, -3, 1, -1. Now remember, that was the plus. Now we're at the minus. So we're subtracting, and then again there's a 1 times, and now we're looking at the minor for this one. So it would be 3, -2, 1, -1. 3, -2. Skip the second row, go to the bottom row, 1, -1. And now that was the minus. Now we're going back to the plus. So this is plus, again, 1. Now we're looking at this 1 times everything that's not in the same row or column as that last 1. So 3, -2, 5, -3. 3, -2, 5, -3. And now we just evaluate the determinants. So we're going to have, on this first one, crisscross. So 5 times negative 1 minus 1 times negative 3. That's minus 3 times negative 1 minus 1 times negative 2 and then plus 3 times negative 3 minus 5 times negative 2. So 5 times negative 1, that's negative 5. And then negative 3 times 1 is negative 3, so this is minus negative 3, which is going to be plus 3. Minus 3 times negative 1 is negative 3. And then negative 2 times 1 is negative 2, but it's minus negative 2, so that's plus 2. And then plus 3 times negative 3 is negative 9. 5 times negative 2 is negative 10, but it's minus negative 10, so it's plus 10. And then we further simplify. Negative 5 plus 3, that's negative 2. Minus negative 3 plus 2 is negative 1. And plus negative 9 plus 10 is 1. So we have negative 2 minus negative 1. So that's negative 2 plus 1, which is negative 1, plus 1, which equals 0. So since the determinant of x1, y1, 1, x2, y2, 1, and x3, y3, 1 does equal 0, we can say that 3, negative 2, 5, negative 3, and 1, negative 1 are collinear. So if we're asked if 3 points are collinear, we want to use determinants to determine if they are collinear points. We have to remember the order of the signs: plus, minus, plus, minus, plus, minus, plus, minus, plus for the rows. And then the form x1, y1, 1, x2, y2, 1, and x3, y3, 1, the determinant equals 0. So then we just substitute in our points. Expand according to that last column. You could expand according to whatever row or column you wanted to, as long as you remember these signs up here. But it's easiest to use this last column because they're all 1. So we're just multiplying each one of the minors by 1. That makes things a lot simpler than if we're using the other values in the determinant.